Hey guys, welcome back to a new video in which we learn how to write test cases for our app when we use Koin for dependency injection. I have another video for Koin dependency injection specifically, in which you would just learn how to apply dependency injection for your app with Koin. Now we want to learn how to test our app, write test cases with Koin. So in this video, we'll have a simple app that when we click on a button, we get some data. We will try testing the process of clicking on this button. Do we actually get the data? So this is an end-to-end test or a UI test, you could say. We'll also test our view model. Does the view model actually get the data? And then we'll test our data source, which is some sort of a data source that we get the data from. And we'll see, do we actually get the data, the right type of data? Because now we will have two types of data. Do we get the correct type of data when we want it? Now let's see how to do that. Here I am in Underwood Studio, and I already have this project that I set up. I will also leave the link to this project in the description. You can just copy whatever you need from it there. I have dependencies or libraries for Koin, local tests, and instrumented tests, or Underwood tests, you could say. Those tests that need to access the Underwood resources like context and more things like that. Okay, so in Koin, simply that's a bundle that has all the Koin libraries, and also for local tests, that's a bundle that has all the local test libraries, and for instrumented tests also more of these. And here they are. Maybe I don't use this one, but I think I'm supposed to be using it somewhere here, but I don't know. Anyway, we have this one, but it's not used. We have the Koin libraries, local test libraries, and instrumented test libraries. These two are simply shared between the local tests and the instrumented test. So Koin test GUnit 4 and Koin test. Okay, so these are the specific libraries for testing with Koin, and of course we have them in both local tests and instrumented tests. Now let's just go through these libraries and see what they are. So GUnit is a core testing library that we need. In this case, we are using GUnit 4 actually. And truth is for assertions. To assert is a value, actually what it's supposed to be. More core testing libraries, and now testing with coroutines and Koin testing libraries, which are these two. Again, truth for instrumented tests or Underwood tests, and then GUnit, just core testing libraries so far. These are all needed for instrumented tests. Testing with coroutines, Expresso to test our UI, and then Koin tests, okay? So these are libraries that we need. And the versions, of course, for Koin, local tests, instrumented tests, then GUnit that is shared between the two. Great, just paste these and sync the project. And also, I always, when I add these testing libraries, I always get an error, and the only way to solve it is by adding these two lines, which are these two. Maybe you will also have to do that. And then I'm also using the latest Kotlin compiler extension version. I'm using Java 17, and of course we use Jetpack Compose. That's it. That's all you need. Put these in your Gradle file and sync. In the project, I have two packages, Core, in which we have all the shared or common classes, utilities, whatever that is shared between different features, and then the specific feature. And in Core, what I have is just my main activity and this UI package, which I have theme, type, and color. And then in my main activity, I just call my feature screen. Of course, I have no navigation. And then we have app, in which we have now our feature module, which is something we'll see. So right here, DI, our feature module, we'll see that. But first of all, in presentation, we have this feature test tags, in which we have the tags that we need to test our UI, which is we have two buttons, one to get data type 1, and then the second one to get data type 2. And then I have my view model itself that needs this feature data source or repository. And then I have the state that is just an empty string at first, but then when I call this function, I get the type of the data that I want that I pass from here, and that is in the end a string. In my screen, I have that view model, as you can see, Koin view model, just a screen like this with a text that displays the data that I get from the view model. And in the first button, I try to get data number 1, and here the text says get number 1. And then in the second button, I tried getting the data number 2, and here, as you can see, the text says number 2. Here I'm just adding this test tag, of course, for testing, to be able to perform a click on this button when testing our UI. Also the same for the first button, which is type 1 and then type 2. And then there comes our domain layer, which we have this feature data source with a single function that returns a string with the type of data that we want, and then the data in which we have the local feature data source, which could also be called the repository implementation. We have our DAO that we just get the data from. If we are trying to get data number one in the DAO, get data number one. If you are trying to get data number two in the DAO, try to get data number two. The DAO in this case is just a class with two functions. Of course, this also be a real room database DAO with a real database. Here I have application to assume actually getting the data from database or so. In this case, the data source is just my strings file. So you can see I have two strings, type 1 and type 2. That's what I get with my function. So that's the app. And that's the typical structure that we would have in a clean architecture app. Also, if you want to build an industry level solid app with clean architecture, MVI and databases, APIs, and also building a Ktor backend, then check out my premium course that I will leave you in the description, in which we learn how to build these to take your skills to the next level and become ready for the industry. So that's the typical things that we have: a data source, a DAO or some database or whatever, some data source, a local data source to get that, and then an abstraction for that, and then in our ViewModel we try to get it. Now in our DI right here, we're just trying to provide our feature DAO, as you can see, that needs, of course, application that we pass with get right here. And then we're trying to provide our local feature data source, that is this one. Of course, we could also provide it in this way. It's the same thing. These two lines really do the same. Of course, this is bound to our feature data source interface, which is this one, or abstraction. And then we're trying to provide our view model passing this one, that is our feature data source, that is get. We have that in here, in our module, in application, and then the underwood context, which is of course registered here in manifest. So that's the app. We can run it and see what that looks like before writing the tests. So this is the app. When we click on get type 1, then we get type 1. When we click on get type 2, we get type 2. That's the app. Great. Now let's actually start testing the app. The first thing is we want to test our DAO, which is this one. So for that, we want to open it, right click on it, generate test, and we want JUnit 4 in this case, feature DAO test. That's exactly what I want. Okay. And then that's going to be an underwood test since that needs application. Great. Now click on OK. The test is generated, which is this one. But before actually start writing the test, we need to set up some things for Koin right here. First of all, let me just remove this, and here is now my future DAO test with the same package structure. So right here, I need an instrumentation test runner. So that is needed for underwood tests all the time, which is going to look something like this. And now we want to copy, first of all, let's copy the package name right here and go to our Gradle file. And then here we want to replace this underwood unit runner with our new instrumentation test runner. We want to just paste our package name like this, or the package structure in which this instrumentation test runner exists, and then we want to copy the name, paste it like this, because now we're trying to use this new one in which we'll have our testing app, because technically we already have this application right here in which we have our application in our modules. But now we want to have a testing application, which means we just want to copy the name, come right here, create a testing app. This is going to be a class technically, and then that extends application. We will have the onCreate function, and oops, bring that back. We want to start Koin again, just like this. For application, it's going to be a little bit different. It's not going to be like this. In fact, now it's going to be underwood context again. But for the context, it's going to be instrumentation registry, which is this one, dot get instrumentation dot target context dot application context. That's how we can get it. Let me just maybe bring this to a new line like this so you could see. That's how we can get now context for testing. And then we want to have our module as always. So module or modules are the same, but in here we have our feature module, which is for production technically, but for testing we want to have now our, I don't know what it was called, so maybe I don't have it. So let's now create the module as well. So in my feature, I want to create a new package called DI, in which will have now my testing feature module. So it's going to be like, say test feature module. That's going to be an object, and let's see what I need. I'm just going right here. I need my DAO, and let's just paste that right there. Actually, it's not going to be an object. I'm sorry, it's going to be a module. So var test module is going to be equal to module like this. It's a mistake I made. So we need our DAO. Why? Because in rule database, if you have a DAO, then you also have an in-memory database for testing, which is something you can find in the testing playlist that I already made. So you can just simply use your real DAO, but create an in-memory database that is just a database for testing. But the reason why we need this feature DAO is that we want to test it in our feature DAO test. We won't actually use it to get the data when testing. We just want to test that we actually get the data within the DAO, not from the repository or somewhere else, okay? So that's what we need it for. And for instance, if you have a database, then it's going to actually look something like this. An in-memory database builder like this, in which you just have a database with no name, since this is only for testing, okay? If you just have a database, then you can definitely just copy this. We also want our data source and our view model as well. So we can just copy both of these to save some time, paste them right there. But of course, I don't want all of this. Let me just delete that. What I want here is a fake data source, which is something I don't have, and I also want to create it first. But before that, let's just actually do that later. Let's first test now our DAO, which is something we need. Since we now have we have provided our feature DAO, which is this one, we want now to use our module right here, which is our test feature module. Now we can test our DAO. So that's going to be, of course, a class. And what we need is testing our DAO. And this is how you could technically create it, but we can initialize it right from here. We can say private var is going to be feature DAO of type feature DAO by inject. Okay. And to get this inject, we just need to extend here Koin test. Now we have access to this inject. We can just import it like this. Great. Now we have our feature DAO injected to our feature DAO test, which now we can use to test. And let me just create some space down here first. And the thing I want you to know is that if you have a database, then you want to close it after testing. So you would have something like an after function like this, which is tear down. Actually, we don't want to stop Koin, but we need to actually stop our database. So it could be something like database.close if it's a Roam database, something like this, okay? If you want to stop it. And of course, if you have the database, then also that's going to be database of type some database like this by inject. But right now I don't have a database, but I'm just telling you, if you have a database, that's how you could use it and that's how you could provide it. Great. Now we can already test it. So let's get the first testing function. So add test like this. That's going to be a fun. Now the first thing is we want to write what the test is. So get type or get data type 1, for example. And then what we expect is data of type 1, for example, of type 1. That's what we expect from this test. So we want to get the data type 1, and then we expect the data to be of type 1. Now, what we want to use is truth for testing, or for assertion, I mean, truth like this, dot assert that. What we want to assert is that we want to use our feature DAO, get data of type 1. But this is a blocking function or a suspend function. And for that, we're going to say that our function is equal to run test like this. You could technically also use run blocking, but don't, since now we are in a test. This one is customized for testing, you could say. And we can assert that, we can just bring this to a new line, assert that it is equal to what we get from our database type 1 like this, right from here. So assuming that we are getting now this from our database, and we can just duplicate this for the other one, which is get data type 2. Is it actually type 2? And here as well like this. Now let's just run both the tests at once. We'll just run one of them. I don't know what's going on here. Maybe I need to sync. I don't know. I can't run the test. Okay, now the app is synced, but yeah, now I can run the test. It was just because I needed to sync. Since this is an underwood test, it will reinstall the app because it needs now the emulator. Okay, since we need context in our DAO, and we can only get the context from our device. That's why we need the emulator. And the test passes. And to make sure that it's actually working, let's say here we're trying to get data type 3, which is something doesn't exist, and we want data type 1. Now the test shouldn't pass. It should just complain that we did not get what we expect, as you can see. Now let's run this other test and let's see if everything is all right. And if you keep an eye on the app here, it actually reinstalls since this is an underwood test, and the test also passes. So our instrumented test to test our DAO is working just great with Koin, as you can see, Koin test. The next thing is let's create a fake data source. To do that, we can just probably just copy this, paste it in here, and then let's name it, for example, a fake underweight, since it's only for underweight, because maybe we would also want to have another one for local tests that is not for underweight. So a fake underweight data source. And of course, since we just want this data source for our end-to-end test or our UI test, we don't actually need to pass anything to it. When we want data type 1, then we can simply get test type 1, and then we can just copy this, paste it here for the second type. That's great. Now we have our fake underweight feature data source that we can go now to our feature module or testing feature module, and let's create some space down here. We can already uncomment, and here we want our fake underweight data source like this, double comment at first. Here for the view model, we can now provide this as well. That takes a feature data source, which is exactly this fake one. And in here, maybe you also want to copy this and have it right here, if you want to write it in this way. And it doesn't take anything actually. It's just like this. You can write it in any way you want. That's it. And the next thing is we want to create now an end-to-end test to test our UI. So what that is let's open the emulator right here. Let's make this a little bit small so you could see. There's another thing. I don't know. I don't think this is the app actually. Let's just rerun it. That is, I'm going to click on this button, make sure that type 1 is displayed in the screen. Click on this button, make sure that type 2 is displayed in the screen. That's the end-to-end test or the UI test that we want for our app. And let me just close everything I have open. And I don't know if I just, for example, go to our presentation screen right here and I try to generate a test. Can I do that? Yeah, I can. And there is going to be feature screen test. Okay, click on OK. That is going to be an underweight test since we're trying to test UI. And that's it, the test is generated. That's also going to be a Koin test like that. I don't need a view model or anything. All I need is my activities, since that's where the screen exists. So I need a compose rule. If you don't understand what I'm going to do right now, please watch my testing playlist in which I explain these in boring details, how all of this UI test thing work. In this case, now I need a rule, which is at get rule like this, and that is var compose, let's say compose rule is going to be create underweight compose rule, and that is for my main activity. Now I can use just this compose rule to perform clicks on buttons, swiping, navigating between screens, and all those stuff. Okay, since now if we go to our main activity, we call that screen from our activity like this. Okay, and we can start writing the test. That's all you need simply, and that is again going to be at test like this, and the UI test is going to be on, let's say, click button, for example 1, and is type 1 displayed. Okay, that's going to be the test. And then we want to use our compose rule dot on node with tag. It's going to be my feature test tags dot button type 1. Why? If we go to our screen somewhere here, check the first button, it has this test tag, which is a button get data type 1, which is exactly what we need to get right here. You just close this now, and then what we want to do is to perform a click on it. Now we will click on the button with this test, and then we want to make sure that the type 1 is actually displayed. So that's going to be compose rule dot on node with text now, since that's a text, and the text we're trying to display is what we have in the fake underweight data source, since that's where we get it from, and that is somewhere right here. So we're trying to get test type 1. Okay, so as I said, we just created this fake underweight feature data source, test our UI, and that's what we are trying to get. Dot assert is displayed, and simply you want to copy this for the other one here too, here as well, and then I want to click on the second one, and then make sure that the second one is displayed. It's run the test. That needs, of course, the underweight emulator, and you will see that it actually clicks on a button to actually display that text. Wait for it. And yes, as you can see, the app launched and it clicks on that. And if I delete, for example, one, the test now will fail since it won't find that, okay? It won't find this text in the screen after clicking on the button. And as you can see, the test failed. And I just need to run the second one since now I know that the first one is working properly. Also, it's working just great. So that's how you do UI tests in Koin. The last thing is unit tests. So now I want to test our view model, which is something we want to do a lot, actually. We did a unit test, like it's not that we didn't. This feature DAO test, this is a unit test. And this is a UI test that we did with our screen. Next thing is actually doing a local unit test with our feature view model that doesn't need any underlying resources. So that's going to be generated test and our feature view model test. Okay, now it's going to be a unit test. Let's say a local unit test. Delete this. And now we can just maybe also close this and open this one, in which now we have this future view model test. What we need for every, not exactly every unit test, but for unit testing like this, local unit test, we need a main coroutine rule. That's a must to actually have. Why? Because if we check our view model, we have this view model scope.launch in which we do this stuff. And sometimes just that we're trying to test, do we actually get the data? And it happens that we want to assert that is the data what we want before even getting it, since now this one is launched in a different context. And this main coroutine rule is just what we need to fix those issues, okay? And we'll see when actually we need it. And simply what this does is that it replaces the main dispatcher with just this test dispatcher so that we can actually control it in our test. So as I said, if we're trying to display data or assert that data is what it's supposed to be even before getting it right here, then that's a problem. So we need to stop the execution of our test until we actually get the data. All of that with the help of this main coroutine rule. And okay, to test our view model, we need, of course, our feature data source. And technically, we already have this one in Underwood, which is this fake Underwood data source. But now I want to create another version, which is our, actually copy it with the package, or I can't do that. So let's just see what the package structure is. So right here in future, that's going to be data. It's not that much. So data, paste it, but now it's going to be fake feature data source or fake local, whatever you want to call it, fake feature data source. It's not for Android and it's going to be the same. It's not going to be any difference. We just want to use it to test now our view model. Great. So let's go to our view model test and let's start with it. Again, this is a class and we need two different rules. So it's going to be at get rule var. The first rule we need is an instant task executor rule that is going to be instant task executor rule like this, which is used to make sure that all the tasks or the executions that we are executing in the main dispatcher, that is of course now replaced with this test dispatcher. So of course we could also control that in our test. Great. The second rule we need like this, get rule, that is now our coroutine rule. So it's exactly this one. And as I said, this one just to make sure that we replace the main dispatcher with this test dispatcher, so we could pause or resume the execution of our test depending on did we actually get what we want or not yet or whatever. Great. That's all we need for rules. Next thing we need now is our data source. So private, let's say vol fake, or just call it data source like this, is going to be my fake data or feature data source. And that is needed in our view model, which could be a private vol feature view model. Let's just call it view model for simplicity. So view model is going to be my feature view model passing my data source. Great, that's it. That's all I need. I can now already start writing the tests. So that's going to be add test for the first one to get the data type 1 and make sure that we did get the data type 1. So fun backtips like this, and that is only allowed in local tests, doesn't work in Underwood tests. So again, it's going to be get data type 1, and then what we expect is data of type 1. That's it. Let's now use our view model dot get data type 1. So this one, we will now pass 1 to our function in the data source to get the data type 1, and then after that we'll update our state. Okay, so we want to make sure that the state has data type 1, so it's going to be again truth dot assert that ViewModel dot state data dot is equal to what exactly. Let's go to our fake data source, to this. We can copy this, paste it right here, and it's a string. Now it's correct, but what will happen is that we will get to this part of the code in which we try to assert is data what we expect it to be before even finishing this, because as you can see, we now use a different context, which is the view model scope, okay, or a different scope. And to fix that, that's why we have this main coroutine rule, that we pause the execution of our test until all the other tasks are executed, which is in this case the view model one. So we want to use our main coroutine rule dot dispatchers dot scheduler dot advance until idle. So until everything is good, then we can assert, and we can just copy this and paste it. Now we're trying to get data type 2, like this. And if you want to see why I'm saying this, now let's run this without that line that pauses the execution of our test. Test will just fail. But if we bring it back, we rerun our test, the test doesn't fail. It's just working. And to make sure that it's actually fine, let's say we try to get data type 3, which is not correct, and will fail again since it's of type 3 and we want type 2. I mean type 1, I'm sorry. And now we can run the other one, which is of type 2, and it also works just great. So we wrote local unit tests, instrumented unit tests, and also UI tests. And all of that for an app that used Koin for dependency injection. If you want to know how to do exactly this with Daggerhill, then you can find my testing playlist in which I use Daggerhill. Now I'm just using Koin. It's the exact same thing, but with different syntax and nothing else. And if you want to become ready for the industry of Android, then check out my premium course in which you will build an industry level app with its Ktor backend, and you will use all the industry skills like clean architecture, databases, APIs, which are all the things that you actually need in the Android industry. And also, if you want to support me, then leave a like in this video and subscribe to this channel. See you in the next video. Bye.